Hey calculus, today we are going to learn how to set up a definite integral to find the area between two curves. So in our first example, we have the line x plus 2 right here, and we have the parabola x squared minus 2x minus 2. And we want to find the area that is between those two curves. All right, so there is our area. To find this area, we have to set up a definite integral. All right, so we need our limits, we need a function, two things that make up a definite integral. The function, which is called the integrand, and the limits, a and b. All right, so to find the function, you have to subtract your equations. All right, and in order to determine how you subtract your equations, you need to put in a rectangle in this shaded region. All right, now how you determine if it's a horizontal rectangle or a vertical rectangle is no matter where in this region you put it, the rectangle that you put in has to hit both functions. So this example, it has to be a vertical rectangle. All right, because no matter where I put in a vertical rectangle, it's going to hit both the line and the parabola. Whereas if I put in a horizontal rectangle, I could put it in down here and it would never hit the line. So that's how you determine what kind of rectangle. It has to hit both functions no matter where you put it. Now, if you have a vertical rectangle, you are going to key in on the y values. All right, so you want to visualize a point at the top of the rectangle and a point at the bottom of the rectangle. The point at the top rectangle is on the line, and the point on the bottom of the rectangle is on the parabola. So visualize those two xy points. And again, you want to focus on the y values. So when you subtract your equations for your function, for your integrand, you want to subtract the higher y value function minus the lower y value function. Okay? So in this case, at the top of the parabola, the higher y value is the line, and the bottom of the parabola, the lower y value is the parabola. So we are going to take the line minus the parabola to write our equation. All right, so let's go to work. Our line is x plus 2. And when we plug in that second function, you have to put it in parentheses so you remember to distribute that negative. So when I put in my parabola, I have x squared minus 2x minus 2. All right, and now we're going to simplify this. We're going to distribute the negative. So we get x plus 2 minus x squared plus 2x plus 2. And finally, the last thing to do is we need to add like terms. So we have only one x squared term, negative x squared. We have an x and a 2x. That gives us a positive 3x. And finally, we have a 2 and a 2, and that gives us a plus 4. So there is your function for your integrand. All right, so we're halfway there to setting up our definite integral. We have our function, our integrand. So again, when you put in a vertical rectangle, you key in on the y values, and it is always the higher y value function minus the lower y value function. So in this case, it's the line minus the parabola. You plug them in, you distribute your negative, and you add like terms. So that is your first step, finding your integrand. The second step is to find the limits. So to find the limits, we are going to set our functions equal to each other. All right, so we're going to find our limits, a to b. So we're going to take our equations and set them equal to each other. X squared minus 2x, x squared minus 2x minus 2, and we set it equal to x plus 2. Now the easiest way to solve this is to get everything to one side and get it equal to 0. So we're going to subtract off x from both sides, and we're going to subtract off 2 from both sides. So we're left with x squared minus 3x minus 4 is equal to 0. Now, when you have a quadratic set equal to 0, you can either factor it and use the zero product property, or you can use the quad formula program on your calculator. This one is pretty easy to factor. We can split up x squared with x and x. The only factors of 4 that will give us a 3 are 4 and 1. Since we need a -3 sum, this has to be negative and this has to be positive. So we get a solution of 4 and a solution of -1. And you can also get those using the quad formula program on your calculator. All right, now look at the graph to make sure that these limits make sense. Let's go up here to the graph. This is the farthest part of the shaded region on the left. That x value there is -1, so that makes sense. This is the farthest part of the region right here on the right. If we go down to the x-axis, that x value is 4. So we're going from -1 on the x-axis all the way out to 4. So the limits that we got algebraically make sense when you look at the graph. So make sure you check before you add them in. So now we go back to our integrand from -1 on the bottom to 4 on the top. And there you have it. There is our definite integral. That will help you find the area of that region. How do you solve a definite integral? That is the fundamental theorem of calculus. First step, we find the antiderivative. All right? To take the antiderivative of this function, that is 3 power rules. The antiderivative of -x squared is -x to the third over 3. So we pull out the 1/3, -1/3 x to the third. Now we keep going. The 3 comes along for the ride. We get 3x to the second over 2. So that gives us 3/2 x squared. And finally, the antiderivative of 4, using the power rule, is 4x to the first over 1. So the antiderivative of 4 is 4x. And don't forget to put a bracket on the end of your antiderivative to bring along the limits. All right, that's the first step, fundamental theorem of calculus, to solve a definite integral. Find the antiderivative, bring your brackets along to bring along the left and right limits. And what do we do with those left and right limits? That is the second step of the fundamental theorem. We plug the upper limit, the top of the bracket, into the antiderivative, and then we plug in the lower limit, the bottom of the bracket, and then we subtract. So when I plugged in when I plugged in 4, I am getting 18.667, and when I plug in -1, I am getting -2.167. This negative and this negative here become positive. So when we add those, we get an area of 20.83. And that is an area unit squared. All right. So to recap, to find the area of this region, we have to set up a definite integral. To get our equation for our definite integral, we subtract our functions. The higher y value minus the lower y value function. The top of the rectangle minus the bottom of the rectangle. And then we distribute the negative and we add like terms. To get the limits, we set our functions equal to each other. And we solve for x. And to solve that definite integral, we use the fundamental theorem of calculus. We find the antiderivative using a bracket on the end of it to bring along our limits. We plug our limits into the antiderivative and subtract. So there's our first example.